Welcome back. In today's video, we're going to build a 4-bar linkage parallel grabber. Works by a trigger. These jaws open and close. And we can grab stuff with them. We're going to go through the design and kind of an explanation of how it works. Then we'll do print bed setup and how to print so that we don't need support. And last we'll do assembly. Let's look at how this guy works. In the middle, we'll start from the inside. We have a double rack gear and pinion. So a rack gear on either side of this trigger piece that runs between these two pinion gears. When we move this back and forth, we turn the gears. So as this guy is extended outward, the gears rotate clockwise, and on the way back, we get counterclockwise rotation. So clockwise rotation opens the jaws and counterclockwise closes it. As we pull back on this surface with our finger, we're closing it and grabbing with the jaws on the end. And as we push forward with this finger, we're extending. This is a 4-bar linkage. The distance between these pivots and these pivots is the same, and the length of these arms is the same. So as we twist here, these guys stay parallel, these guys stay parallel. And that means the grippers stay parallel. So we have these awesome parallel grippers that no matter how far apart they are, they're going to present these faces parallel. So we can grab things of any size, and we don't end up with situations where the jaws are tilted one way or another. If you've ever tried to pick up something round with faces that aren't parallel, you tend to squirt it in the open direction. It shoots right out of your jaws. This guy won't have that kind of a problem. You've got very positive motion, and when you grip with it, you have a really good grip. We're transmitting most of the force through and not losing it to friction as you so often do in 3D printed parts. And this thing actually does a nice job. We've needed to create rotating interfaces in a bunch of places, and we've gone with large clearances because as this gets tight, it's not a lot of fun. You want it to be very loose, and then it moves, and we've tried to accommodate a bunch of different printers on this, so we didn't go too tight. We've got a roller in here that keeps this trigger moving in a straight line, because without it, we would be able to pivot about here, and this would go all over the place. So this roller is making sure that this moves straight backwards and forwards, and for all of these pin connections, we kind of use the same trick. So if we section this, if we look at this pin, we've got half a pin sticking out from either side. We've arranged them so that they come through and they're concentric and they form one pin together. And this is 2 pins in single shear, but it effectively gives us a single pin in double shear, which is what we were after. And that really does mean in order to break this, you have to cut through it 2 different times. And this is really double single shear, not double shear, but it's kind of the same thing. All of these pins come half from one side, half from the other. These guys too, and they meet in the middle and they form one long bearing surface that is stronger than a single one sticking out of the side. We used our tapered interference features here. So you squeeze this together until you make these faces contact, and you've got to already have these over the pegs, and that's what holds the whole thing together. Same with this one. These are the same jaws reversed, so that they face the opposite direction. Then these posts, the little guys, we're pivoting on the large diameter, and we're using the small tapered diameter to hold the thing together, and it pilots in the hole on the opposite side. And same with back here. We have this spacer holding this apart so that there's room for this to live and slide. And then we've got the peg sticking up that interferes with this slot to hold the handle together. So that's kind of the whole thing. It all works in 2 dimensions. And as this guy moves back and forth, it's kind of held straight by here and here. The rack teeth on this turn the pinion teeth on these guys. They're synced and they move at the same time. So that as you pull this back, these jaws meet in the middle. And as you push it forward, you open it up nice and wide. And this is the stroke limit that keeps you from moving it any further forward. So that's max you can open the jaws. And on the way back, you usually hit this, but it's possible with clearance that you'd hit this back wall. And I was fine with either one, so we kind of left that alone. Here's the print bed setup. For the sides, the handles, we want to face the posts up and put the flat side down. This trigger piece just prints on its side, and that'll give us the best strength through these teeth. We've got a few chamfers on it that we can print overhangs, so this will be fine. You've got 2 different jaws. This is one of them. It's going to print post side up, and the other jaw is this guy, which is also going to print post side up. And that will allow us to print these features that hold it together, and this one too, and make sure that the draft goes the correct way in this one. It'll print either way, but you don't want those posts down or you're going to need support. These struts either side, they're identical, doesn't matter. Same with this roller. Just put it on its end. We want it to print very round. These pinion slash linkage arms, we just want to put on their side. We'll print these overhangs, and this is so that you don't have to have a wavy back and forth motion on your print bed. The side that's down looks like this too, so the first layer that it's going to print of this big arc instead of a bunch of changes of direction. And I find if the teeth print directly on the bed, you end up with errors there. Sometimes it doesn't stick and then your part suffers. So this way, the first time that it has to go through these sharp turns, it's off the print bed. It's printing out in the air and it sticks much better to plastic than it does to the bed. That's all the parts. So print them like this and we'll look at assembly next. Here are all the parts we should have printed. We're going to start with one of each jaw. And we put the posts up. The strut goes like this. And then these guys, the gears want to face towards the inside. So it goes on there and on here. And then same thing on the other side. So strut there. And then this guy goes on this post. Next, we're gonna close them and get them good and even. And then we put this guy on, we're gonna mesh it with the teeth and move it as far back towards this as we can. And you're gonna find a spot that it fits down. And then the roller goes over the post in the middle of the slot. And then we should be able to move this if we're really careful and keep it on the table. The whole thing should operate. Next, we're gonna take the opposing jaw. So post goes in the hole goes over the post. And the pins go into the two holes in the yellow parts. So here and push down, and then here, push down, they should lock together. And that completes the jaws. Last piece is the opposing side. We've got to get these two posts into these two holes, and then this goes in the back in the handle. So line all of this up, push straight down, and now we're done. So you push forward on this part to open them and pull back like a trigger, and then we can just grab stuff. That's it, we're done.